Right. Composite figures, or area of composite figures, or composite area. Basically, a composite figure is a figure that can be separated into regions or shapes that are basic plane figures. So if you get like an irregular shape, right? Doesn't have a name to it. You can split it up into simple shapes like triangles, parallelograms, trapezoids, rectangles, circles. To find the area of a composite figure, you're going to divide up the regions, not actually dividing, just like splitting it up, and then find each area. And then find the sum of those areas. And then we're just going to add the areas together. Oh, you know what? I don't like divide. I'm going to put split. Split up the regions. It's up to you. It means the same thing, but I don't want you to be confused with actual division. Okay. So whenever I have a composite figure, I try to identify the simple shapes I see. So the first simple shape I see in number 1 is I see a rectangle. The area of a rectangle is length times width. Hopefully you see it very clearly right here. 12 times 23. $276. The next shape I see is the trapezoid down here. So this shape right here is my trapezoid. And the area of that is a little bit more complex. It is that 1/2 times the height times the two bases added together. So let's identify the different parts we need. So we have base 1, base 2, or base 1, base 2. This one's going to be 23. I'm just copying it over from the rectangle up top. And then all I need is the height. If I drew a segment here, I'd have 90 degrees, and that's the relationship between height and bases. They're going to be perpendicular, but I'm just going to put it outside. So from here to here is 12. If this whole segment is 18, then that means this much is 6. The height of this trapezoid is 6, and we have our two parallel bases. Remember, the bases are always parallel to one another. So here's what we have. 0.5. I like to change the 1/2 into 0.5, makes things easier for me. The height is 6, and the two bases are 23 and 15. So that's 0.5 times 6, and I'm going to add these two up. That is 38, huh? Which is going to be 114. So then to find the area of the entire figure, I'm just going to take those two areas and add them together. That's it. And when we do, we get 390 centimeters squared. If you just put 390, that's fine also. That's essentially it. You'll get like maybe 2 or more area problems in one shape, and you just have to add them up at the end. All right. Okay. Number 2. This one Try not to overcomplicate things. When I first saw this one, you guys, I thought, okay, so I have two semicircles, which makes a circle. I can just treat it like one circle. And then I thought I had a trapezoid and then a little triangle. And I made my life so difficult by doing it that way. When in fact, this is simply just a parallelogram. So the area of a parallelogram is base times height. Always look for 90 degrees when we're trying to identify who's the base, who's the height. And so the height is 5. You can put a little h there. The base is missing. I have 6 here in this semicircle. So what is this entire length going to be? We can assume that they're going to be the same. What's this entire length? If it's 6 and 6, it's going to be 12 for the entire thing, from here all the way to the end, right there. So the base is 12, the height is 5, the area of this parallelogram is 60. We have 2 semicircles, so we can count that as just one circle, separated, but one together. Area is pi r squared. I know there was circumference formula on the notes yesterday, but we're doing area. And the radius is 6, pi 6 squared, which is 36 pi. You can go ahead and round it here. That's fine. I do have students who like to save the pi until the very end. They do 60 plus 36 pi. That way they don't have to round it twice. So it's up to you. But you don't technically have to round it again if you just add these two. It just comes out as is. So the composite area is 60 plus 113.1, which is 173.1. And the units is inches. And we indicate that it's area by putting a little square there. And that's it. All right. Okay. Number 3. We have a triangle, and what's this? Oh. What's this one? I almost said it. Half a circle. What's that called? Yeah. Let's deal with the triangle first because there's going to be a little bit of work that we have to do for it. So, triangle. And then we'll do the semicircle, as you've called it, second. That's going to be 1/2 base times height, or 0.5 base times height. Base and height will have a 90-degree relationship, so I don't have that. I'm going to draw it in. And when I do, I've split the base of this triangle into 8 and 8, and I'm trying to find the height. So off over here, I'm going to do leg squared plus leg squared is equal to hypotenuse squared, and h is going to end up being 15. So here's an error, or like just an oversight that I saw a lot of you making yesterday. When you did the triangle formula after doing the Pythagorean theorem, I saw y'all doing this. 0.5 times 8 times 15. If you put 8 in as the base, you're only finding the area of half the triangle. This is when you have to go back to the full base of 16, and then of course the height that we found, in order to get the area of the entire triangle. So just be aware of that. That's actually a very common error. If you do that, no worries. Just multiply your answer by 2 at the end, because you basically just found the area of half the triangle if you put 8 in there. That's it. All right, what's that? So that's going to be 120, I think. 120. And then let's find the area of the semicircle. You guys, the area of a circle is pi r squared. So what do we have to do at the very end of that to make it a semicircle? Yeah, so you could just do bam and add that to your formula list if you'd like. In our formulas for now, like the formula sheet, you can use the back of your homework log. I just put in the shapes there. You can add in the formulas as you go. Ooh, what's radius? 8, yeah. Just so I can reiterate, you can put that in your calculator as exactly as you would say it. Pi r squared divided by 2. And your calculator will do everything in the correct order. You don't have to worry about parentheses or anything like that. And that'll get us 100.5. And then lastly, the composite area is going to be 120 plus 100.5, that's going to be 220.5. And if you'd like to label and keep that consistent, meters squared. If we were just finding perimeter or another length, we would just put meters. But since it's area, we're going to put square. Any questions on composite figures? Adding up the area, that's it. Find the simple shapes, find the area of each, and add it up. Okay, so now we're going to do shaded regions. To find the area of a shaded region, we find the area of the entire figure, of the whole thing. And then subtract the area of the non-shaded region. So here's how I like to think of this. We have a shape, and then we cut out another shape from it. So for example, number 4, we had a square, but we're cutting out a circle from this square. So I always like to do the entire shape first, which is a square. Right? Area, side squared, so we're going to be doing 25 squared, which is 625. Now the shape that we're cutting out, so I call it the cutout, is a circle. The area of a circle is pi r squared. So formulas don't change. It's just what we do at the very end. It's different from page 1. We need the radius. That's going to be half of 25. Do you guys know off the top of your head what's half of 25? 12.5. Good job. Okay, and if you plug that into your calculator, pi 12.5 squared, we should get 490.9. So what's different from the first page? It's not that we're combining, we are removing the white portion of this figure. It's been cut out, that's why it's white. So let's call this shaded area equals the entire thing minus the cut out portion, 625 minus 490.9, and that will result in 134.1. And because it's still area, feet squared. All right. What is the shape of the entire figure, of the original figure before we did any cutouts? All right, go ahead and find the area of this rectangle. And the shape we're cutting out is a triangle. Area of a triangle is 1/2 base times height. Anytime you have a B and an H, we're looking for a right angle. Looks like we have 11, and then this is missing. However, we can transfer it over from the original rectangle. 25 base and height. Okay, so we didn't have to do any work ahead of time. We could just go ahead and put everything in to our formula. 0.5 times 25 times 11, 137.5. Okay. Shaded area. We are always subtracting. 350 minus 137.5 is 212.5. And of course, if you want to do units, centimeters squared. All right. Do you guys have any questions? All right, then we'll just finish up the notes. Number 6, we have 2 more. Number 6, the entire shape. The outside is a semicircle. Entire is a semicircle, which means it's half a circle. So if a circle's area is pi r squared, I'm going to cut that in half eventually. Oh, but I don't have anything right here. So if this is a center right there, I don't have a diameter to work with. I don't have a radius, but I do have this triangle. It opens up to half a circle. I know there's actually technically not enough information for this, so go ahead and add that center in there, and let's just assume that it was already in there. It really should have been in there from the beginning, which means that this is a 90-degree angle because it's opened up to half the circle. So that center is actually necessary, so we're going to add it in, and we're going to pretend that it's always been there. So then, in order to find the radius, either here or here, we're going to have to find the hypotenuse of this right triangle. Leg squared plus leg squared is equal to, let's call it D for diameter squared, because it will be the diameter of the entire semicircle, this whole thing. Okay, so if you guys do that, if you end up doing that, 9 leg squared plus leg squared equals hypotenuse squared, you will get 23.4. So if the entire diameter is 23.4, how do we find radius given the diameter? What do we do to the radius? What do we do to this to get just... Yeah, okay, thanks. Just checking for a pulse, you guys. Divided by 2. So our radius is 11.7. Now we can proceed with this formula. 11.7, and then because it's a semicircle, we're going to take the area of a circle and cut it in half. pi 11.7 squared divided by 2. And you should get 215.0 is our area of a semicircle. And then all we have to do now is find the area of the cutout shape, which is a right triangle. Cutout is a triangle. 1/2 base times height. Base and height always have a 90-degree relationship. Here's a 90-degree. Base and height, or the other way around is fine. Base and height, it really doesn't matter. And you just plug it in. 0.5 base and height. $97.2. And so our entire figure was 215 and our cutout was 97.2. So to find our shaded region, what the region that basically got left over, we're going to subtract. And you don't have to put the 0.0. And you'll get 117.8 meters squared. All right. Okay, last one, you guys. Last one. Do you guys know what this shape is? The entire shape. Remember what this is called? I don't think I was very explicit with the shape names with you all yesterday. This is called a trapezoid. So the entire shape is a trapezoid. And that's this little number. A is equal to 1/2 times height. Base 1 plus base 2. Anytime you see a B and an H in a formula, we're looking for a 90-degree angle. There's one right here, but that's missing. So we're going to have to do a little detective work. And let me grab my black pen because I have to write inside this figure. What I'm going to do is I'm going to draw the height I need in here. I'm going to do a little detective work so that, away from here, so that I can just find it. If this is 17, this is 17, which means out of this entire 37, this part is 17, which makes this part 20. So I'm looking at, just cover this up, this triangle right here. A right triangle where H and 20 are the legs and 25 is the hypotenuse. Leg, leg, hypotenuse. So what we can do is leg squared plus leg squared is equal to hypotenuse squared. And you will get a very nice number. It's 15. If you eventually do that Pythagorean theorem. 15. So we have the height, that goes in there, and then we have the two parallel bases. It's going to be 17 and 37. So at this point, we could just ignore these two. Now let's plug it in. Oh, I like to do 0.5, so let me do that. 0.5, and the height we found of 15, and our two bases that is connected by our height is 17 and 37. So 17 plus 37, is that 54? Should be. Well, anyways, if you do all of this, you get 405. What's the shape that's being cut out? The shape that is being cut out is a semicircle. All right. So a semicircle is simply area of a circle, and then we cut it in half. Okay, so the only thing we need is the radius. Let's looky here. Okay, still no writing there. However, let's take a look. If this is 15, that means this is 15 as well. But that's the diameter. If I cut 15 in half, I get 7.5 and 7.5. I only need one of them because that's the radius. So that's what we're going to plug in. Area equals pi r squared, 7.5, and then eventually cut that in half. 88.4. And then last step, so we found the two areas. We only want the gray region, the shaded area. So we're going to take our entire figure and subtract, remove the cutout portion. And we get 316.6. Okay, and that's it.